Mixing music for live sound reinforcement comes with a variety of challenges. I couldn't possibly cover everything in a single video, so let's focus on the challenges that come along with mixing vocals in a live setting. I'll discuss some of the problems that we face in live sound, what you can do as an engineer to mitigate these issues, and a few design principles that microphone manufacturers employ to optimize a microphone's performance in a live sound environment. Thanks to Heil Sound for sponsoring this video and supporting audio education. I'll be showing off a couple of their designs today, the popular PR37 and the new wireless capsule version of that mic, the RC37. Links to both of these are available in the description below the video. The first challenge that we deal with in live sound reinforcement that isn't usually a problem in other settings is that of microphone feedback. This is the ear-piercing squeal that we all know and love. The issue arises when the signal from a microphone is sent to speakers within the vicinity of the microphone. At a certain point, the speakers will be so loud that an infinite feedback loop will be created. The microphone signal is amplified through the speakers, then the sound from the speakers is picked up by the microphone and amplified again, each round getting louder and louder. One of the most important things you can do to prevent microphone feedback is to minimize the amount of speaker signal that reaches the microphone. And there are a few ways you can do this. First, you can utilize distance. As you know, sounds are quieter the further you are from the source. And by this same logic, you can increase the distance between a speaker and a microphone to increase the amount of gain that can be applied to the microphone signal without feeding back, often called the maximum gain before feedback. Another characteristic of the system that helps increase the max gain before feedback in a particular situation is the directivity of the speaker. Most speakers used in live sound will output most of the energy forward toward the audience, with very little energy radiating from the rear. This is especially true at higher frequencies. Therefore, it's recommended to point the speakers toward the audience and to place the microphone behind the speakers so that as little energy from the speakers reaches the microphone as possible. Many microphones are also directional, and this is by design. A microphone's polar pattern will impact how it responds to sounds based on the angle at which the sound approaches the microphone. For example, an omnidirectional microphone will theoretically pick up sound at all frequencies evenly from any direction. Meanwhile, a cardioid microphone will reject sound that approaches from behind the microphone, and you'll also find bidirectional microphones that pick up sound from the front and rear and reject sound from the sides. The most common polar patterns used in live sound are cardioid and supercardioid. These polar patterns allow for increased gain before feedback, as well as decreased leakage from other nearby instruments. All you have to do is point the microphone so that the unwanted sound reaches the microphone at one of the points of maximum rejection. The Heil RC37 and PR37 have supercardioid polar patterns, which means they pick up sound best from the front and reject sound from just outside the rear with a small lobe directly behind the microphone. This can be ideal for live situations, particularly vocals. And here's why. Think about a floor monitor wedge on stage. If you were using a cardioid microphone, you'd want to point the rear of the microphone toward the speaker on the floor to reject as much of the energy coming from the speaker as possible. This can be ergonomically inconvenient for singers, though. If you use a supercardioid mic instead, you can point the microphone directly toward the vocalist, and because the rejection point of a supercardioid mic is slightly to the sides, the speaker can be more easily placed in the rejection zone. Using these techniques and tools, directional speakers, directional mics, and proper microphone placement, you can maximize the max gain before feedback of your system and save everyone's ears from that dreadful squeal. In addition to the issues that arise as a result of the placement of the microphone relative to the speaker, you can also encounter challenges associated with the placement of a microphone relative to the sound source. In this case, the vocalist. If a singer holds the microphone further away, you'll need to use more gain to achieve the same signal level, and you already know that increasing the gain increases the chance of feedback. The closer the vocalist gets to the mic, on the other hand, the less gain will be required to achieve a given signal level. However, proximity to a directional microphone comes at a cost. Because of the proximity effect, you'll hear a buildup of low-frequency energy as the microphone is placed closer to the sound source, which could make for a muddy vocal sound. Ideally, the vocalist will be a moderate distance away from the mic and will sing loudly into the microphone, increasing the amount of vocal relative to surrounding noise and energy from nearby speakers. But if the vocalist sings quietly and they hold the microphone too far away, you'll likely encounter some problems. One of those potential problems is microphone feedback, as we've already discussed. But there's another problem that can be just as challenging if your goal is a clear, well-balanced mix. That's the problem of leakage from other instruments and noises. Noise from the audience will be mitigated by distance and the polar pattern of the microphone. However, the microphone's polar pattern won't help us when the noise comes from the same direction as the vocalist. For example, we almost always place the lead vocalist directly in front of the drummer, and this places the cymbals directly in the area where the mic is most sensitive. That can be particularly problematic as the frequency range of the cymbals overlaps with the frequency range of the vocal. This problem can be mitigated by using distance, although that's not often possible on small stages. It can also be mitigated by placing the drums to the side or behind a barrier, but that comes with some additional acoustical challenges that I won't get into here. For these reasons, it's very important that vocalists project their voices and practice good microphone technique. Poor microphone technique can also impact the max gain before feedback and the clarity of the vocal performance in other ways. The best example of this is when the vocalist cups the microphone in their hand. See, the directionality of a directional microphone relies on the technology that surrounds the microphone capsule. There are ports and labyrinths in the microphone's design that allow it to create phase cancellations at various frequencies by providing various pathways to the microphone capsule depending on the direction the sound is traveling. And if you block these alternate pathways by cupping the microphone, you'll reduce, if not eliminate, the effectiveness of the cardioid or supercardioid polar pattern, making feedback much more likely and negatively impacting the tone of the signal. The best fix for this problem would be not to cup the microphone, but there's only so much you can do if an artist cups the microphone during a performance. Fortunately, some microphone designs are less susceptible to the negative effects of cupping the mic than others. Thanks to the open design of microphones such as the Heil RC37 and PR37, the pathways are more difficult to block with poor microphone technique. Even if I cup the PR37 in my hand, the tone remains relatively consistent compared to some other mics that are more closed on the rear. Now, I'm not here to talk trash on other microphone companies, so we're going to keep the model of microphone I'm using currently secret. But listen to how the tone changes when I cup this very common stage handheld microphone. You can hear that cupping the mic dramatically alters the tone of the sound, and it will also dramatically alter the ability for the microphone to reject feedback. Compare that to the sound of the Heil PR37, and you can immediately hear the difference. This design also helps the microphone reject potential feedback when cupped. Therefore, using a mic like this can save you in situations where the vocalist cups the mic. Not to mention the fact that leakage from other instruments is often more pleasing with this type of microphone design compared to the leakage that you'll experience when using a more closed design microphone. Of course, microphone technique is a factor in studio recording as well. However, you can often use compression and clip gain to resolve these imbalances without worrying too much about leakage and without worrying at all about feedback. In live sound, these techniques can exacerbate the problem or cause new issues to arise. So it's best to use tools and techniques that combat the impact of poor microphone technique up front. Rarely will a studio vocalist be holding the microphone in their hands or holding a microphone stand in their hands. This makes handling noise a non-issue in normal circumstances within the studio. However, in live performances, the vocalist will commonly remove the microphone from the stand, hold the microphone in their hands, switch hands, etc. And for this reason, microphone companies take special care to reduce the amount of energy that's transferred from the chassis of the mic to its internal transduction elements. This can be done in a variety of ways, but Let's open up this Heil PR37 and see what techniques were used in this case. We can immediately see that there's a lot going on in a relatively small amount of space. Microphone developers go to great lengths to utilize space efficiently. Handheld microphones are not only built with shock-absorbing materials to help them be more rugged, but also to prevent structure-borne noise from being transferred from the chassis to the signal chain. In preparation for this video, I visited the Heil Sound factory to get a closer look at how these microphones are made. And as engineers and musicians, it's easy for us to take for granted the end product and its performance. But all of these components you see here have to fit inside the microphone in a way that minimizes electromagnetic interference, reduces handling noise, and ultimately sets us up to perform or mix a show without the common problems I've mentioned in this video. Check out the links below to try a Heil microphone for yourself. And in the next video that's on your screen now, we'll be taking a closer look at microphone polar patterns and how they work. I'll see you there.